integration in business. So last week we would have looked at techniques of integration. We looked at the product rule, the power rule, quotient, and the chain. Right, so today we're going to look at how we would apply those in the field of business. All right, so we're going to look at some examples. It says an apartment complex has 250 apartments to rent. If they rent X apartments, then their monthly profit in dollars is given by this function here, which is Px is equal to negative 8x squared plus 3200x minus 80,000. So this is the profit, right? How many apartments should they rent in order to maximize their profit? So this is the profit function. They want to know how many apartments should they rent in order to maximize profit. So something you must note, in order to maximize or minimize, to get the maximization, minimization of a function, you always find a force derivative of that function, or you differentiate with once. Right? So all that we are really being asked to do here is to maximize the profit subject to the constraint that X must be within this range. X must be within the range of 0 and 250. So it says an apartment complex has 250 apartments to rent. If they rent X apartments, then their monthly profit in dollars is given by this function. How many apartments should they rent in order to maximize their profit? So basically, they will have to rent between 0 to 250 apartments because they don't have more than that, right? That's the range. All right. So they wanted to know what's the number of apartments should they rent in order to maximize their profit. And to do that, all they simply need to do is to differentiate their profit function. So let's differentiate this. This becomes, these two got to come in front. That becomes negative 16x plus 3200. This becomes 0. Right? So this is called the force derivative. This little dash here on top means the force derivative, the function p of x. So all you need to do now is to solve for x. What's the value this x should be in order for us to have the maximum profit? Right? And to solve for x, simple. We have negative 16x is equal to plus 3200 is equal to p of x. So I'm going to bring this over here. That becomes negative 32. 100. Right? And then we solve for x. X is equal to negative 3200 divided by negative 60. Right? And that would be 2. So in order for us to have the maximum profit, we will have to rent out 200 apartments. Any question here?
Yes, what become of the 80,000?
It becomes zero. When you differentiate, there is no, it's a constant term. Recall when you differentiate, a constant becomes zero. From the, you are in last week lesson. Can you now recall that when we differentiate the constant, it becomes zero, so that becomes zero, all right? So maybe you may tell yourself that in order for us to maximize our profit, we may have to end up renting out all the apartments, but that's not true. Sometimes you may encounter more our costs, maybe more than our, in order to maintain this maximum of 250 apartments. So according to this profit function here, it shows you that in order to maximize our profit, we need to rent 250 apartments. So it says, since the profit function is continuous and we have an interval with finite bound, we can find the maximum value by simply plugging only the critical point that we have, which is nicely enough in the range for acceptance. So notice here, we have our maximum function. If we are to plug in 0 apartments, let's look at that. This is your profit function. Let me just clear this. This is your profit function here, right? If you are to rent out 0 apartments, it simply means that wherever you see X, you're gonna put 0, right? You're gonna end up having negative 80,000, which means the negative value, we are running at a loss, right? Maybe it costs them 80,000 to maintain these apartments. If we are to rent out 200 apartments, and if you plug in 200 in X here, you end up making a profit of 240,000. If we are to rent out all the apartments, 250, we end up making 220,000. So you see, if in order for us to get a maximum profit, which is 240, we are to rent out 200 apartments instead of 250. Any question? Let's look at an example. A production facility is capable of producing 60,000 widgets in a day, and the total daily cost of producing X widgets in a day is given by this function. Now, this is your cost function. This is the cost of producing X widgets in a day. How many widgets per day should they produce in order to minimize production costs? So as I would have mentioned earlier, whenever you're asked to maximize or minimize, you always find the force derivative of the function given. All right? So let's differentiate this. So I'm going to take a minute and differentiate this and tell me what you have. Take a minute. Finish. So notice it goes to 0, right? We should have 250. Let's rewrite it. You need to bring this up. The power there is 1, right? So when you bring it up, the power becomes -1. Did you guys do this? So it's 200 million. All right, to x to the -1. So this goes to 0, right? This goes up and you just leave with 0.08. There's a -1 on top here, right? So you bring that in front, so it becomes -200 million. X. Because we had to -1 in the power, so it becomes -2 now. Any question here? That's what you guys have? So you people can talk to me so I can move on. All right? So that's your C, your first derivative of C of X. Right? So they recall, so we had, and I work it out, had 2 million to the x to the -2 power. So I bring that back and becomes, I explain this when it's a negative power, right? It means that this is in the denominator. So I bring that back into the denominator. Is this clear? Student?
Yes.
Yes, miss.
And if you find a second derivative of this guy, right? This can go off, right? This becomes 0. You got to find, if you got to differentiate back this, and then we have to bring this back on top here, right? So you can bring the -2 in front, and this becomes positive now. And then we'll end up having -2 minus 1. We get it to the 3rd power now. So we have 2 times 2 million give us 400 million. And that's x to the 3rd power. So that's how we get this one. So you know to do that from last week's class. So let's not focus on this, but once, so in order for us to minimize our cost, we already have our function here. Now let's solve for x. So we got 0.08 minus 2 million over x squared is equal to 0. Take the equation equal to 0 and we solve, right? How do you solve for this? So I want to take a few minutes and work this one out, right? Take a few minutes and work it. First thing you do, you bring this over here. Trying to make x squared the subject. So what you do, you take this guy. First thing you do, right? Take this, put it over here. Becomes 0.08. Right, so that is no longer there. Next step, take this over. This division here becomes multiplication. So it's multiply by x squared. And this alone will remain over here, right? 200 million. So we have 0.08 x squared is equal to 200 million. So to get rid of this square, right, we got square root this. So the first thing you need to do, we gotta get rid of this 0.08. If it's multiplied here, bring it over, becomes divide. Divided by 0.08. Right? And when if you have $2 million, 200 million divided by 0.08, you'll end up have 2 million. I'm getting tired. I end up having 2,500 million, right? And then to get rid of this square, you square root this value here. So the value for x is equal to plus or minus 50,000. But notice x can be negative because the question asks how many widgets should they produce in order to minimize their cost. So it can be negative widgets, right? It's going to be positive 50,000. So it's going to be positive 50. Let's look at, so note, I'm going to recap. If you're asked to maximize or minimize a function, you're always going to differentiate and solve for x. Find the first derivative and then solve for x. Can somebody read for example 3 for me?
The production cost per week for producing X widgets is given by Cx is equal to 500 plus 350x minus 0.09x squared. X is more than or equal to 0 or less than or equal to 1,000.
Right. So x can be within this range, within the range of 0 to 1,000 widgets, right? Answer each of the following questions. What is the cost to produce the 301st widget, right? What is the rate of change of the cost at x equal 300? So this is our cost function. They never ask you what you must do to minimize or maximize our profit, right? Minimize the cost. So basically, the cost of producing the 300 and not 301 widget, you know, the 301st widget, right? So we can just compute 301 in our cost function, producing, as that is the cost of producing 301 widgets, while we are looking at the actual cost of producing the 301st widget. In other words, we are looking for here is this. So if we basically go and plug in 301 into this function, can anybody tell us what does that give us? The value that we will obtain here, what will that give?
The cost of producing 301 widgets.
Yes, we don't want that, right? We just basically wanted what's the cost of producing that 301 widget, right? Not 301 widgets. So basically what we can do, right, is Find the cost of producing this 301 widgets. And then we subtract the cost of producing 300 widgets, and that will give us the cost of producing 300 and 301st widget. You think you got it? So when we plug in 301 in this function, right? When x is equal to 301, we're going to get this value. Yeah, I don't know how to do that. It's going to be 500 plus 350 times 301 minus 0.09 times 301 square. We're going to get this value. When we plug in it for 300 now, we're going to get this value. So the difference is 295.91. So the cost of producing the 301st, which is actually this value here. Clear? Now, when you're talking about what is the rate of change of the cost at x equal 300? Now, when you're talking about rate of change, now is where the calculus comes in. Right? The rate of change of producing, what is the rate of change of the cost at x equal 300? And to do that, you're basically going to find the first derivative of the cost function, right? Anytime you think about rate of change, you're finding the first derivative of the function, and then you plug in. Then you're going to plug in when x is equal to 300. So let's go back. Let me just go back. Okay? Let's differentiate this. Differentiate this class. Work this one out for me. Take 5 minutes and work it out. So what you need to do, right? You're going to differentiate this function. And then whatever you leave with, you're going to plug in x equal to 300. Find that first, and then you're going to plug in and x is equal to 300. Take a 2 minutes and work it out. Finish. And let's look at it. So this is 0, right? That's gonna be 350. Minus 2 times 0.09. What do you have?
0.18.
And then we're reducing this power by 1, right? So just gonna be x. So the 1. And now you plug in wherever you see x, you're gonna put what? 300. Or we can get. What we get here?
296.
Oh, good job. Everyone understand that? Right. So our rate of change is $296. So just what we did learn in this example, the cost to produce an additional item is called marginal cost. Something to note, these are terms that are going to come in your test. The cost to produce an additional item is called marginal cost. As we have seen in the above example, the marginal cost is approximated by the rate of change of the cost function. So we define the marginal cost function to be the derivative, the marginal cost function to be the derivative of the cost function. So to find the marginal cost function is basically a derivative of the cost function. So let's look at some examples. So notice, we were looking back at the same example, right? The production cost per day for some widgets is given by this. Oh, this is different. Let's see. Yeah, cost function is different. So the production cost per day for some widget is given by this. This is your cost function. What is the marginal cost when x is equal to 200, x is equal to 300, and x is equal to 400? So to find the marginal cost, you're going to find the rate of change of your cost function, which is basically the first derivative of your cost function, and then plug in these values. So work this for me. First, so what you need to do is to first find the derivative of this guy, and then you're going to plug in these values. All right, just like we did. Find the derivative of it and then plug in the values. And you should end up with this, and this. So take 5 minutes and work it out. And if you have any problem, you can discuss it. So in your notebook, you can make note to find the marginal cost. It's basically the rate of change of the cost function, or finding the first derivative. Because to test some of these will be coming, right? Students, anyone with anything different? Any questions? Any questions? Just need to know in order for me to move on. So this gives you the rate of change. So when you find the first derivative and you plug in that values, right, for x, so it tells us that to produce the 201st widget, it will be $10, right? To produce the 300, there's the next widget, right? The next product, it will cost us $38. The rate of change give us that. And to produce the 401st widget will cost us $78. Right? So if I go back here, note here that the cost to produce an additional item is called the marginal cost, right? And the marginal cost is approximated by the rate of change of the cost function, which is basically the first derivative of it. So we'll define the marginal cost function to be a derivative of the cost function. So that's what you did just now. Note that it is important to note that the first derivative, right? This is your first derivative. This is your first derivative of your cost function of n is approximate cost of producing the n plus 1 item, and not the nth item as it may seem to imply. Right? Notice here, the first derivative of your cost function, right, of n is the approximate cost of producing whatever value that you get here plus 1 item. Right? So if you find like just now, if you go back here, notice the marginal cost of 200 give us 10, but this is going to give us 200 plus 1. So it's 201 or 201st widget. This 300 there is going to give you this 38 is the cost of producing a 301st widget. Right? Not 301 widgets, you know, the 301st widget, the next widget. Now let's turn our attention to the cost, the average cost function. Average cost function. And as the name suggests, average cost function. If Cx is the cost function for some item, then the average cost function, which is going to be C with this little bar on top, right? It means the cost function, the average cost function, that's what it means, is basically the cost function divided by x, right? Note, the average cost function is basically the cost function divided by x. There's a cost function here, C of x by x. So when my x is 100, my cost function is going to be From here, we touch it and you go across. Step 5, 10, 15. Somewhere like 1, 5, 10. Looks like 17, somewhere around that. 17 units. We can see from that the average cost function has an absolute minimum. We can also see that sorry, I got something popping up on my screen. Let me just open. Just give me a minute. We can also see that this absolute minimum occurs at the critical point where the average cost function C of C bar X is equal to 0. Since it is clearly will have a horizontal tangent here. So basically what they're saying here that the absolute minimum will occur when you find the first derivative of your average cost function and you equate that to 0, right? So let's move on to some example. We'll have some discussion and we'll go into the next. Now we could get the average cost function, differentiate that, and find the critical point. However, this average cost function is fairly typical for average cost functions. So let's, instead of differentiate the general formula above using the quotient rule and see what we'll have. So we're going to find the first derivative of our average cost function. Okay. And I would have discussed it just now. Note that the absolute minimum will occur when you set this guy equal to 0. First derivative of your average cost function is equal to 0. And this is what's going to happen. All right, so this is basically x times the first derivative of your cost function minus the cost function equals 0, which gives us this. All right, as I would have mentioned earlier, first derivative of x is equal to cost function over x. So to find your average cost function, it's going to be your cost function divided by x. So we can see that it looks like for a typical average cost function, you'll get the minimum average cost when the marginal cost is equal to the average cost. We should note, however, that all average cost functions will look like this, not all of them. We should note, however, that not all average cost function will look like this. So you shouldn't assume that this will always be the case. Now I'm going to go on to some formula, which is called the demand function, price function, revenue function, and the profit function. Let's now move into the revenue and profit function. First, let's assume that the price that some item can be sold at if there is a demand for X units given by PX. PX is this function here. It's typically called either the demand. Notice this, right? There's some questions will be coming. This function here, lowercase px, this is called your demand function. or the price function. The revenue function is basically how much money is made by selling X items, and it is denoted as this. This is the formulas. And you will use Rx, uppercase R, X. So represent revenue function. And that is, you calculate that revenue function, the revenue can be found by X, the number of units, times your demand function or the price function. The profit function now. So this is my revenue function. My profit function is basically this guy. Profit function is your uppercase P, right? Demand function or price function is a lowercase. Profit comes with an uppercase P, right? Know this. And to find your profit function is basically your revenue, money that comes in, your revenue function minus the cost function, right? And the revenue is basically X times the demand function minus the cost function. So to find our marginal, always note, right? If you're asked to find marginal, you're just basically going to find its forced derivative. So here is the formula. Marginal revenue function. All you need to do, right? Marginal revenue function, all you need to do is to find the forced derivative of this guy. When you hear that term marginal, right? And the marginal profit now, you're going to find the forced derivative. So you guys can make note of this. You're going to make the forced derivative of your profit function. So when you're talking about marginal, that's something. Take a few minutes and make note of these formulas, and then we're going to work. Right, let's move to an example. And you're gonna work this one for me. The weekly cost to produce X widgets is given here, right? That's your cost function. And the demand function is this guy. So the weekly cost of producing X widgets is this, where X is within 0 and 1,000 widgets. And the demand function, this, again, where X is within 0 and 1,000, because you can't demand what you're not producing, right? Determine the marginal cost. So you know just now how we're going to find the marginal cost. You get the formula, right? Determine the marginal cost, marginal revenue, and marginal profit when 2,500 widgets are sold and when 700 widgets are sold. So you gotta do it for 2,500 and 7,500. Assume the company sells exactly what they produce. So make use. Do you guys have the formula, or should I have to switch back so you can take a picture of it? Everybody okay? I assume so. So answer these questions and then we're going to discuss it. Everyone finished or still working? Just let me know if you need more time. Student?
Still working, Miss.
So I'm sharing the answer with you so you can follow as you work. Right, here is the answer.
Excuse me, miss. Can I see back the first slide? Thank you, miss.
Finish? Correct? Let's discuss it. Are you guys ready? So let's find our revenue function. So can you tell me the formula for revenue function? It's going to be x times what? Student? So I'm talking to 45 students. At least one body should know. To find the revenue function is going to be x times 1. Times which function?
Demand function.
Right. And this is given, right? For your price function. And when we did that, it happens to be this x times that gives us. So that's our revenue function. Any question there? What is PX for? Profit function, right? How do we find the profit function? Come on.
You expand the project list.
No, what's the formula for profit function?
It's the revenue function
Mhm.
minus the what's this one? It's the revenue finance minus the let's see, the CX. The CX.
Yes, and CX is called. All right, anyone. Thank you very much, dear. The CX is called what? As the C suggests. Cost function, right? It's common sense. To find your profit function is basically the revenue comes in the revenue function minus your, is not the revenue minus the cost, right? So it's going to be the revenue function minus the cost. When you did the math, it's going to work out to be this. All right, so in this case, always note in algebra, right, you're going to group the like terms and then you're going to perform the necessary operation. So there's an x square here. You're grouping the x square with the x square, right? You're grouping the x. There is no, there's one x. There is one x cubed. So we bring back, that's negative 75,000 plus 100x, right? X squared now. Negative 0.005. The negative here, and there's a negative, so it becomes positive. So we're going to get negative 0.005 plus 0.03. You add that, you will have 0.025x, right? And that's a negative here. This negative govern everything here. So that's a negative, this value here gonna be negative and the minus value. So this here is our profit function. So everybody were able to get these? So let's find our marginal functions. The marginal function is basically, if I find the first derivative of the cost function, this is called my marginal cost function, my marginal revenue function, my marginal profit function. So when you find your first derivative, it will work out to be this. So the cost function was given, right? When we differentiate that, we get this. The revenue function was this. When you differentiate this, we're going to get 200 here. We bring this 2 in front here, and then we minus. So we're going to get this. Profit, this becomes 0. That becomes 100. Bringing this 2 in front here. Bringing this 3 here. And that's minus 1. We get 2 here. That's how we get this. So these are our marginal functions. Marginal cost function, marginal revenue function, and marginal profit function. Clear? So the question asked, if you guys, can you guys read the question? I think we have to find the cost function, the marginal cost function, the marginal revenue function, and the marginal profit function for these values, right? So we plug in those values. These are what we get. So the marginal cost function for 2,500 widgets are $25. The revenue function is 175, and therefore my profit will be 150. And then you are asked to do the same thing now when you would have sold 7,500 widgets. And you basically plug in. So when I sold 7,500 widgets, I have 325 as my cost. Plus my revenue is 125, and my profit is negative. Look, made a negative, you made a loss. See, you made a loss. So upon producing the 2,501st widget, right? The 2,501st widget, the company is going to make a cost, is going to have a cost, sorry, of $25 to produce the 2,501st widgets. It's going to cost them $25. And they will see a revenue coming in of $175. Therefore, they'll make a profit of $150. On the other hand, if they are to produce 7,500 widgets, therefore, when they produce and sell the 7,501st widget, it will cost them an additional, look here, much money it's gonna cost them? $325, but they're only gonna get a revenue of $125. Therefore, they made a loss of $200 in profit. Any question?
Yes, Miss. Miss, I got all the parts you were discussing. The only thing I want to ask you, for the profit function, which is the revenue subtract the cost function. Can you go over how you did the subtraction? Because I didn't know what you did with the 200x, and I was trying to figure out there.
Here?
Yes, Miss, that part. Can you just do back the
Okay.
subtraction?
So you're grouping it. This is algebra, right? You're grouping the like terms. There is a 200x here, and there is a 100x here, right? You're grouping those x together. You're grouping the x squared together. You're grouping the x cubed, and you're grouping the ones without the x, the constant term, right? So we get 200 here minus 100. And that's how we get 100x. Clear? It's like having 200 marbles minus 100 marbles. So we got marbles, we got buttons, we have clips.
It's clear, Miss. It's clear.
Yeah, you just group them based on their variables, right? Same thing here. That's a negative 0.05 with this one here, right? And notice once you have a negative here and in the bracket, that negative sign governs everything in here. So these are some practice questions, right? And they're pretty simple, right? So I am happy to announce that this has brought us to the end of our course. So that's it for MNG 1101. We've covered the course outline. So next week, because these questions here, I already explained, you have them on Moodle, right? So we won't have any tutorial today. You can just look at the answers. I have the answers. Right, the answers are on the board. So next week, Thursday, you'll have test 3. Right, test 3 gonna be next Thursday. Okay, so we have a tutorial session today. So it's 7 now, and we can meet back at 8 for it. So you guys can take your dinner now, and we can come back at 8. Any question before we go?
Mr. Tutorials on calculus.
Yeah, last week.
Okay, miss.
But for
Yes,
this
ma'am.
practice question, we won't have any session next week. We're done, right? This is our last week. So after today, we won't have back any session for this course. We're done with the course. So with
Excellent,
these
ma'am.
question here, I have the solution. You can just go through them. Yeah. You'll take next week to study for your test. We'll have our test 3 next week, Thursday. It's test 3. And then the following week, right? After test 3, you'll get that week off, to study and prepare for test 4, which is going to be the next week, 24th, we're going to get, no, that's the
The
4th.
15th, the 15th.
Yeah, the 4th is going to be test 3, right? And then the 5th, we're going to get the next week break. And then the 15th is test 4, and you're done with the course. But in terms of lecture, we are done, right? Somebody was saying something?
Yes, miss. Could you please upload the recordings for this lecture and the last lecture?
The last lecture it's not there?
No, miss, on calculus.
Oh, I don't know. I'll upload the last one, and after I'm finished the class on Thursday, I'll upload this.
Thank you very much, miss.
Any other question?
Test 4 is when, miss? Good night.
The 15th. 15th of December.
Miss, can you say what space
Thank you.
that?
I think we would have discussed that already. We put it up. Yeah, that's fine. See you. So test 3 is going to be everything on linear programming. Here it is. Oh, the date is here, but I think this is, oh, yeah, the third. It's a mistake. Should have been the 4th, right?
Yes, look
Is
at
it-
the
yeah,
first at the
it's-
bottom.
Oh, yeah, yeah.
Test 3,
Yeah.
December 1.
Yes, yes. And test 4, we're gonna get on the 5th, right? So here is what is coming.
Miss, I see you have revision and then final exam. Is there a test 5?
No, this you're not getting it. This is used to be the, before we used to get, there is no such thing, before the continuous assessment, right?
Okay, miss.
So as I